Welcome back to Applied Algebra. In this section, we're going to finish up the third method for solving systems of linear equations, and this third one is called substitution. So in this one, what we're going to do is we're going to go ahead and solve the exact same question that we did in section 1 and section 2. So we started with this x plus y equals 1, 2x minus y equals 4. We solved it by graphing. Then we solved it by addition. So now we're going to solve it by substitution to show you that any of the methods work. So the purpose behind substitution is that you want to take something that you already know that it is equal to and plug it in. If the equation looks, or the system looks like this one, where nothing is already isolated, your first step is to isolate a single variable. So step 1 is to isolate a variable. It doesn't matter if it's in the first equation or the second one, doesn't matter which one it is, but you got to get one by itself. So I'm just going to go ahead and do this first one. I'm going to get x by itself. So to do that, I'm going to move the y. Since the y is positive, I'm subtracting it. And so I get x equals y 1 minus y. So now what I'm going to do is I'm going to substitute. So I'm going to take this y minus 1 and I'm going to put it right where this x is. So I still have the 2 that's in that second one, but instead of having x, I'm going to replace it with y minus 1. The rest of the equation stays exactly as it is. All right, so I've taken out the x and I've substituted or replaced it with what it is equal to. Notice the only letter in this equation now is y, which will allow me to solve for it. So I'm going to go ahead and do the distributive property. 2 minus 2y minus y equals 4. Put together my like terms. 2 minus 3y equals 4. I'm going to go ahead and bring it up just so I have a little bit more room. So I'm going to get y by itself. So I'm going to minus the 2. 4 minus 2 is 2. And the last step is to divide. Okay, now, as we talked about in the last one, when we graphed, we got negative 1/2 for my y. When we did the addition, we got negative 2/3 for y, and when we did the substitution, we got negative 2/3. So again, addition and substitution can be more exact than graphing can, but we did get the same answer for y. Now to solve for x, it works the exact same way. You take either equation and you plug in. I always find it easiest to take the piece that you already solved for and just complete it. So this is just 1 minus, my y is negative 2/3. So that's 1 plus 2/3, which is 1 2/3 or 5/3. So my answer is 1 2/3 and negative 2/3. It's the exact answer that I got in the last video. Now if you're asking yourself, how do you know which ones to do which methods with? If I happen to have things lined up nicely, like in this top one, where I have x's on top, y's on top, and numbers on top, especially if I already have a positive and a negative, I will do addition. I just find that easier. If I have a single variable already by itself, then I think substitution is easiest to do. So in this case, I'm going to go ahead and take this 4x, and I'm just going to stick it right there where that y is. So it's 2x plus 4x equals 12. That gives me 6x equals 12 divided by 6, and I quickly already have that x equals 2. Now to go ahead and find out what y equals, I'm just going to go right here, and it says to do 4 times your x is 2. 4 times 2 is 8, so my point is 8 and 2, but I started to write it backwards. So remember, x is 2 and y is 8, so I have to make sure I do it in the right order. So the answer is 2, 8. So that was very quick. If I would have tried to do it with addition, I would have had to line up the letters before I worked, and it would have taken a little bit more time. So I'm going to do that same idea here on the next one. I have x already by itself, so I'm going to take this 3 minus 2y and I'm going to stick it right here where the x is. So I have 4 times 3 minus 2y. Then I just keep going, minus 5y equals negative 40. I will do the distributive property next. So I have 12 minus 8y minus 5y equals negative 40. Like terms, 12 minus 13y. I'm going to go ahead and minus the 12. Negative 13y is negative 52. Divide by the negative 13. And I get that y is 4. So then I'm going to come back here, and x equals 3 minus 2. I already found out that y is 4. So x is 3 minus 8. 3 minus 8, my x is negative 5. So my answer is negative 5 and 4. So really, any of these can be solved with any of the three methods. I'm just going through the substitution method. So the last one I just wanted to show you, if you do so choose to do this method with it when it's stacked like this, when the x's are above each other, the y's are above each other, and the constants are together. So I need to get a variable by itself. Again, it doesn't matter. I try and think of numbers that would divide nicely. I don't think dividing by 3, since 2 divided by 3 is not a nice, easy number, I wouldn't do that one. And also 5 does not divide nicely by 6. But dividing by 5 isn't bad. You'll end up with some nice decimals, and dividing by 2 isn't bad. So do either the top or the bottom, top by 2 or the bottom one by 5. I'm going to go ahead and do this top one. And so what I'm going to do is I'm going to go ahead and isolate the x. So I'll practice that right here. So I need to get x by itself. So I'm going to minus the 3y. 2y equals 12 minus 3y. Divide by 2. So y is 6 minus 1.5y. And I do have decimals, but they're not bad decimals. So now what I'm going to do is I'm going to substitute this into the other one. And remember, you always have to go into the opposite equation. So I'm going to put this up here, and all of a sudden I have 2 y's, and so this is 2x. This is an x. I don't know why all of a sudden I turned it into a y. So I have to substitute this in for my x. So I'm going to do 5. But instead of x, it is equal to 6 minus 1.5y. And again, notice I'm putting it in the second equation, not the first one. Minus 6y equals negative 51. Distributive property. 5 times 6 is 30. 5 times 1.5 is 7.5y. And yeah, we're going to get some more decimals, but it's okay. We have our handy dandy calculator to help us out. So I'm going to go ahead and move my 30 over by subtracting it. So I get negative 81. My last step will be to divide by my negative 13.5. I think this goes in really nicely. I think it goes in 6 times, but I want to double check. Yep. So y equals 6. Now that I know what y is, remember you go back here, plug it into what you already knew. X equals 6 minus 1.5 times 6. 1.5 times 6 is 9. 6 minus 9 is negative 3. So my answer is negative 3 and 6. Again, one more time, it doesn't matter which method I would have used, all of these would have given me that answer. So go ahead and work on those. The last section of this chapter will be applying these methods, and I will get back to you on that one. Have a good day.